So hello dear students, as promised, I am starting a course of class 11th ISC board on my YouTube channel, that is SU Square Physics. And students, before starting the course, I just want to give you the overview of syllabus for class 11th ISC board. Let me upload the syllabus. ISC board syllabus. Now, first we will see the total weightage of marks here. As you can see, physical world and measurements, kinematics and laws of motion. The total weightage is 23 marks. Work, energy and power, motion of system of particles and rigid body, and gravitation. Total 17 marks. Properties of bulk matter, heat and thermodynamics, behavior of perfect gases and kinetic theory of gases. Total 20 marks. Oscillation and waves, 10 marks. Total 70 marks. So we'll try to cover this. Within 1 year till January we will complete all this. And students, we will I will not start with physical world and measurement. First I will start with elementary mathematics. I will just give you a simple overview of elementary mathematics, the different mathematics uh, which you are going to face in your class 11th and 12th. So I will just give you the brief overview of that. Uh, I will tell you the syllabus of also the elementary mathematics. It will hardly take 3 to 4 classes. In 3 to 4 classes, we will try to finish the elementary mathematics part. After that, we will start physical world and measurement, second kinematics, and then next is work, energy, and power. Then motion of system of particles and rigid body. Then gravitation. Then properties of bulk matter. Then heat and thermodynamics. Then theory of gases, that is kinetic theory and rest all. And last, oscillation and waves. And these are the practical work. I will just try to upload some of the videos of your practical work and finished. And this is project work. If you are in the school, you will do this project, and practical file is of only 5 marks. So this is all about that. So students, I will start with elementary mathematics. Elementary mathematics. The syllabus is elementary concepts of differentiation and integration for describing motion. So this is the syllabus of your elementary mathematics, and it is very important because you are going to face different elementary mathematics in your 11th and 12th, and you just don't the student what do, they just do the differentiation and integration. They just know why they are doing differentiation and integration. So we will just focus on applied parts. So now, first, students, I will start with quadratic equation. First year, I will start with quadratic equation. Quadratic equation. Students, it is an algebraic equation of second order in which highest power of variable is 2, and it is called a quadratic equation. For example, if you have the equation ax square plus bx plus c, it is equal to 0, where a does not equal to 0. And students, here uh, it's a general quadratic equation, that is ax square plus bx plus c is equal to 0. And here a and b, you can just see a and b, they are the coefficients of x square and x respectively, and c is a constant term. And students, its solution is, as we all know, we have studied in class 7th, 8th, and 9th. Uh, its solution is x is equal to minus b plus minus under root b square minus 4ac upon 2a. This is the solution of the general form of quadratic equation. And now students, for suppose that you have an equation of the form of tan x square minus 27x plus 5, it is equal to 0. And students, if you will compare with the general form of quadratic equation, that is ax square plus bx plus c is equal to 0. Here you will find out that a is equal to 10, b is equal to minus 27, and c is equal to 5. So here, students, we will write its solution. So here, x will become x is equal to 27 plus minus under root b square minus 4ac. So we will do the square of minus 27 square minus 4ac. So here minus 4 into 10 into 5, a is 10 and c is 5 upon 2a. So here it will be 2 into 10. And students, if you will simplify this, we will simplify. So here it is 27 plus minus. And students, the square of 27 is, it is 729. 729 minus 4 10 ja 40, 5 ja 200. So in this way, you have to do the calculation also. You have to break in parts and then do the calculation. Calculation is very simple. And 2 into 10, 20. So here, friends, here it will become 27 plus minus under root 529 upon 20. So here, if you will simplify it further, it will come out to be 27 plus the square root of 529. 529 is 23 upon 20, and 27 minus 23 upon 20. And here, students, if you will simplify this, so you will get the value of x is equal to 50 upon 20, means 5 upon 2, and 27 minus 23, 4 upon 20, so 1 upon 5. So this is the solution. X is equal to 5 upon 2 and 1 upon 5. And students, if you have to further check whether this x is the solution of this differential equation or not, so how to check? Just keep x is equal to 512. Here keep x is equal to 512 and check LHS is equal to RHS, whether it is in LHS 0 is coming out or not. I'm just verifying first. X is equal to 5 by 2. So wait. I am just verifying it. X is equal to 5.2. So here, students, it will become x into 10 into 25 upon 4 minus 27 into 5 upon 2 plus 5. Now simplify it. Here, students, it will become 5 2 jet 10. Sorry, 2 5 jet 10 and 2 2 jet 4. So here it will come out to be 125. So here it will come out to be 125 upon 2 minus 27 5 it is 135 upon 2 plus 5. So here, students, if you will simplify this, it will come out to be minus 10 upon 2 minus 5 plus 5, and it is coming out to be 0. So it means x is equal to 5 upon 2 is the solution of this uh, quadratic equation, that is 10x square minus 27x plus 5 is equal to 0. So then similarly you can check x is equal to 1 upon 5. It will also verify, and in LHS it will come out to be 0. So in this way you have to verify whether the values which you are getting x, it is a solution of your differential solution of your quadratic equation or not. So this was all about the quadratic equation. Now next come to binomial theorem. Next we will see binomial theorem. Binomial theorem. Binomial theorem. So friends, here the binomial theorem for any positive integral index. Positive integral index. Integral index. And it means positive integral index. It means simple numbers 1, 2, 3, and so on. Nothing else. Let me plug my PC because battery is low. Sorry for the delay. Because my PC was in battery low. So students, it's simple number 1, 2, 3. and nothing else. So students, if you have the binomial theorem for any positive integral n, it states that uh, x plus a to the power n, it is equal to n c0 x to the power n plus n c1 x to the power n minus 1 a plus n c2 x to the power uh, n minus 2 and a square plus plus ncr x n minus r a power r plus n c n a raised to power n. So students, a is a constant, and this is the binomial expansion of x plus a to the power n, where n can be any number 1, 2, 3, 4, 5, 6. It is a positive integral index. So n should be in 1, 2, 3, 5, 4, 5. It should be positive also. And students, this NCR, it is equal to factorial n upon factorial r into factorial n minus r. Students, this you will study in detail in your mathematics course also. And total number of terms in the expansion, it is equal to index plus n, that is index n plus 1. So if you have 3x, if you have 3 index, that is x plus a to the power 3, then you have total number of terms in the expansion will be 3 plus 1, that is 4. And students, factorial n, we will see how to find the value of factorial n. Students, factorial n is equal to n into n minus 1 into n minus 2 into n minus 3 to 4 into 3 into 2 into 1. Suppose that students, we have to find the value of factorial 6. So just factorial 6, it is equal to 6 into 6 minus 1, 5, 6 minus 2, 4, 6 minus 3, 3, 6 minus 2, 6 minus 4, it will be 2, and 6 minus 5, 1, so on. And here, if you will multiply this, 6 5 is 30, 3 4 is 12, 12 3 is 36, 2 is 72, it will come out to be 720. And students, if you have to find the value of factorial 5, then you can similarly find out, simple, multiply up to 1. 4 into 3 into 2 into 1, and here you will multiply this, it will come out to be 120, because see how we have to multiply. 5 4 is 20, 23 is 60, 62 is 120. Now students, we will see its importance in physics. Students, in physics, we generally come across the expansion of the form 1 plus x to the power n. This uh, you will come across the expansion, and where students, mod x, it is less than 1, where mod x is less than 1, and n, it may be an integer, it may be an integer. And students, and it can be, this integer, it can be positive and or negative. So it can be positive or negative. So here, students, we will write the expansion of 1 plus x to the power n. So just see how to write it. Here we have 1 plus x to the power n. It is equal to 1 plus nx plus n into n minus 1 upon 1 factorial 1 into 2 into x square plus n into n minus 1 into n minus 2 upon 1 into 2 into 3 into x cube and so on. Students, this is nothing as 1 into 2. Here it's factorial 2. So factorial 2 is 2 into 1. Here it is factorial 3. So here factorial 3 is 3 into 2 into 1. So students, in this way you have to learn 1 plus nx and so on. Now students, since this power, this mod x, it is less than 1. So students, we generally neglect higher powers of x, that is x cube and higher. We generally neglect x cube and higher powers of x because mod x is less than 1. So in physics, you have to just expand up to uh, x square. You have to neglect from x cube. So this was all about the uh, binomial theorem. Next, students, we will see logarithmic series and exponential series. First, we will see exponential series. Then after, we will see uh, logarithmic series. So next is exponential series. Exponential series. Exponential series. Students, uh, as we all know, this is e raised to power x. And students, we can write the expansion of this e raised to power x. And it is generally equal to 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3 and so on. And students, if we have to write the expansion of e raised to power minus x, so what we do generally, we just write minus x in place of x. So here it will become 1 minus x upon factorial 1 x square because the square of minus x, it will be equal to x, it will be positive. So here it will be positive minus x cube upon factorial 3 and plus so on. So this is the expansion of e raised to power minus x. And students, uh, if you have to write the expansion of e raised to power 1, so how you will write e raised to power 1? Compare these two. Here, just put 1 in place of x. So here it will be 1 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3 plus 1 upon factorial 4 and students, if we have to write the expansion of e raised to power minus 1, so how we will write here? E raised to power minus 1, here it will be 1, just put x is equal to minus 1 here. So here 1 minus x upon factorial 1 plus 1 upon factorial 2 because the square of minus 1 will be 1 And here students, minus x cube. So minus 1 cube will be equal to minus 1. So here minus 1 upon factorial 3. And so this is the expansion of e raised to power minus 1. Now students, we will see uh, the expansion, the logarithmic series. Now we will see uh, logarithmic series, logarithmic. Now students, first we will see the expansion of log base e. It is base e 1 plus x. The expansion of this, it is equal to x minus x square upon 2 plus x cube upon 3 minus x to the power 4 upon 4 and so on. And students, now students, if you have to write the expansion of log base e2, just see how to write log base e. Compare from here 1 plus x. Here if you will put x is equal to 1, so here it will become 2. And we have to write its expansion. So students, what we will do here, we will just put 1 in place of x here. So here students, it will become 1 minus 1 upon 2 plus 1 upon 3 minus 1 upon 4. Similarly, you can write the expansion of log base e3, just put x equal to 2 here. So students, now next we will see the expansion of log base e 1 minus x. So here it will become minus x square by 2 minus x cube by 3 minus x to the power 4 upon 4 and so on. And students, there is one more expansion. No, log base e half log base e 1 plus x upon 1 minus x. The expansion of this is x plus x cube by 3 plus x to the power 5 upon 5 and so. So students, this was all about the exponential and logarithmic series. Next, in next lecture, students, we will see about logarithm. We will see about logarithm, and next we will see about trigonometric ratio. So the next lecture will be on trigonometric ratio and logarithmic series, and after that we will start differentiation and integration. So this is all about today's class. If you have liked today's class, then you can like, share, and subscribe my YouTube channel. That's all. Thank you.